Okay, so now let's talk about things. We're going to explain the difference, compare, contrast, just talk about things, all right? So let's talk about the difference between angle, side, angle, and angle, angle, side. And remember, the order of letters are very, let's see if I can spell this next word right, purposeful. All right, the order of the letters are very purposeful. They're not random. I like to say they tell the story or say the path. All right, now what do I mean by that? Let's just draw a random triangle. Doop. All right, now let's look at angle, side, angle. All right, let's call this F-U-N, triangle fun, because this class is a blast. All right, this would be a classic example of triangle, or S-A-S-A. All right, why? Side UF is an occluded side. It's between both angles, both congruent angles. All right, so just how this side is between both angles, the S is between both A's. So the letters represent the angles and side combinations, the order that they're in. All right, now let's compare this to an angle side. All right, here's another triangle. What should we name this? We'll name it triangle cool. We'll spell cool wrong. All right, because math is cool. All right, here's an angle side example. All right, we have an angle, and we have a side. OL is non-included. It's not between both angles. All right. So that's compare and contrast. All right. And just how this side only touches one of the congruent angles, this S only touches one of the A's. All right. So just how it spatially is, it's how it is written with the letters as well. All right. Now let's talk about HL and side angle. All right. Let's talk first off. Let me think about how I want to talk about this. Let's do HL first. All right. Some people say HL is a special form of side angle. I disagree. HL is really a special form of side. But we'll talk about that later. All right, we have a leg, we have a hypotenuse, and we have a right angle. All right, what we really have is an angle, side, and a side. So why don't we call this the SSA? All right, which is a little foreshadow. Oops. I was going to write bad word. I almost wrote bored as silly me. Bad word, don't work. All right, you get what I'm saying here. SSA is a bad word. All right, but HL, not to get too tedious and too thorough, it's really side. Why? This last side right here we'll call X. Well, Pythagorean theorem, if in a right triangle, if we have two sides, we can always use Pythagorean theorem to find the other side. So that's why we don't call HL side-side angle. We call HL, it's a theorem, because we could prove it to be true using Pythagorean theorem. And let's talk about why side-side angle don't work. Let me think about how I want to organize this. All right, this is a hard picture to draw, but let me see if I can draw it. All right, this explains why side-side angle bad. Okay, so we want to draw a picture like this, kind of. All right, that's good. And then this right here. All right, ain't bad at all. All right, we'll call this triangle math because we're doing math. Or we'll just name it. There we go. All right. So what we're going to focus on is triangle MAT and triangle MAH. We're going to show you that they have a congruent side, and angle. Actually, I should have drew this the other way, but oh well. All right. Now, triangle MAT, we'll do in pink. I'll emphasize it in pink. And then we'll highlight the other one. All right, so clearly both triangles have an angle. Let me write this in a different color. An angle M and angle M. All right, so that's an angle. Let me write this a little backwards. All right, now notice how they both have side MA. That right there, that's a side. And something I forgot to mention, this has to be given information, but those two sides are congruent. All right, and then AT is congruent to AH in this case. All right, so this shows you why angle side does not work. We have two triangles, triangle MAT, triangle MAH. They have a congruent side, and angle, but hopefully, clearly you can tell that this pink triangle right here, hopefully you can tell that is not congruent to this triangle right here in orange. All right, pink triangle, orange triangle does not guarantee congruence. That's why side angle is bad. All right, and this kind of answer this question down here. When is the only time SA combination will work? It's HL, but I really like to think if you use HL, you'd use Pythagorean theorem to prove it to be true, which really would transform into side anyways. But let's talk about this next one. Why isn't there an AA or an AAA triangle congruence theorem? Well, I'm going to draw this triangle, and I'm going to say this. And then you want to see something cool? Watch this. I'm going to copy, I'm going to paste, and then, oops, I'm going to make bigger. All right, we'll call this we'll call this A, B, C, A prime, B prime, C prime. So clearly angle A is congruent to angle A prime, angle B is congruent to angle B prime, so on and so forth. But remember, for triangles to be congruent, their side lengths have to be congruent. So all we have to state is that AB is not congruent to triangle, or A prime, B prime. The side lengths are not congruent, all right? So side lengths don't have to be congruent. So that's why angle, or angle, whatever you want to call it, does not work. All right, and then just to finish this out, we got a series of problems of stating if the two triangles are congruent and then how we would know. All right, so before we even start, there's only 5 of them. Individually, none of them are bad or not hard to comprehend. but I understand it can be difficult to remember which one's which. All right. When we were learning them individually, you probably said that makes sense, that makes sense, that makes sense. But now there's 5, so now we have to be able to organize it, be able to identify which one's which, so on and so forth. So those are the 5 options: side, 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 angle, side, angle, side, angle, 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 side, and HL. All right. So again, stuff we just got to be good at: identifying the shared side, reflexive. We have an angle, we have a side, we have another angle. This side is between both angles, so the S is between both A's. So this one is angle, side, angle. All right, over here, we have an angle, we have an angle, we have a side. This side only touches one of the A's, so it's non-included, so the answer is angle, angle, side. Here, again, these 2 triangles, we have a shared side, so this is reflexive, so side, side, side. That really narrows my choices down to just side, side, side. That's only one with 3 sides. Cool. This one right here, we have an angle, we have an angle, we have the shared side again. By reflexive property, the side's between both angles, so the S will be between both A's. All right, remember the combination of letters are very purposeful. Over here, what we got over here, we got a right angle. That's a right angle as well. We got the hypotenuse, we got the leg, so this is HL. Over here, what's going on over here? We got a side, we got a side, we got an angle, and over here, look what's going on over here. We got a side. So this one, what's going on over here? Notice how this angle only touches one side, so this is non-included. This angle over here, let me use a different color actually. This angle is included. All right, so corresponding parts aren't matching up. All right, corresponding parts, it's just haywire. We got an included angle, we got a non-included angle. Triangles ain't congruent. All right, they don't have to be congruent. All right, sometimes you'll see a case where they're not. Don't forget that. Similarly, OMG, we got a side, we got a side, we got a non-included angle. All right, remember, I just went in great detail on why SSA is bad. So again, triangles ain't congruent. Over here in letter 8, let's do letter 8 really fast. We have a side, an angle, a side, an angle, and then we have the shared side. So we see how this angle right here is formed by the 2 congruent angles, or sides. The angle is formed by the 2 congruent angles, so it's included. Side, angle, side. And then just 4 more problems. State what additional information is required in order to know that these triangles are congruent for the reason given. All right, so we need to use angle, side, angle right here. All right. So we have an angle. We have this shared side. So we have an angle. We have this shared side. So really I need angle. Now again, we're gonna have to be let's be a little precise. I need this specific angle and this specific angle. All right, this angle, it's gonna be angle EDF. And this angle is angle DEJ. All right, we have to use 3 letters. So basically I just need to know those 2 angles are congruent. over here, we need to use angle side angle. So realize, even though it's not marked, it's guaranteed that these are congruent by vertical angles. So I have a side, I have an angle. All right, I need another angle, all right, that makes the side included. So that would be that right there. All right, that way this side is between both these angles. Let me put 2 tick marks. So in this case, I can call this angle R and angle X because there's only one angle coming off of this vertex. HL. All right, we got the right angle, we got the leg, we got the right angle, we got the leg. Remember, leg touches the right angle, that's how I know. So hypotenuse is opposite of it, so it's VU is going to be congruent to RS. And then over here, we need angle, angle side. We got this shared side here. So I got to make sure this side is non-included. So angle Q. And then we have this angle here. So I need angle X. Angle X is congruent to angle Q, would force angle, angle side. All right, that's it. Have a good